Okay, in the last segment, we saw that the autoionization of water leads to 4 equations. pH equals negative log of H plus, POH equals negative log of OH minus, pH plus POH equals 14.0, and that the H plus times the OH minus is equal to 1 times 10 to the minus 14th. All right, now because this is a logarithmic scale, our sig fig rules are a little bit out the door. So pHs we will report, or POHs, to 1/10 of a unit, to the 10th place. Okay, it's because the logarithmic scale is based on something that's exponential. Okay, so segment 8 begins here. The concept is if acid is added, H plus goes up, then pH goes down. If base is added, then pH goes up. Okay? So remember what I said was that if OH hydroxide concentration and H plus concentration are equal, okay, so we're going to use this equation. If we call them X, X times X equals 1.0 times 10 to the minus 14. To solve for X, we take the square root. X equals 1.0 times 10 to the minus 7. We take the negative log of that. Okay, so X is equal to H plus. We take the negative log of that, and that's our pH of 7. Okay, so pH of 7 occurs when H plus and OH minus are equal, and that is called neutral. Okay, that is neutral pH. Okay, by the way, this is molar. Okay, so if we add acid, the pH will go down. So when pH is less than 7, that is called acidic. When pH is greater than 7, pH goes up. That means we have more base. And so we're going to call that basic. Okay? And each pH unit, remember, is equal to 1 power of 10. Okay? Okay, so what is the difference in H plus concentration when pH is 4 versus pH of 6? So 6 minus 4 is 2 pH units. 10 squared is 100. 100 times more H plus when pH equals 4 versus pH equals 6. Okay? What is the pH of 7.5 times 10 to the minus 4th molar HCl solution? Well, what you need to recognize about HCl is that it is strong. So if you have 7.5 times 10 to the minus 4th molar HCl, that means you have 7.5 times 10 to the minus 4th molar H plus. And this is easy peasy. You just plug in to pH equals negative log of H plus. So we get out our calculator. Okay, so hopefully, nope, new calculator. So log, see if I can get that in there. Log 7.5 E minus 4, end parentheses. Take the negative of what's in your display, and your pH is 3.1. Okay, I'm not sure if you can see that. Take the negative of what's in your display, 3.1. Okay, now what I want to do here is to remind you, when we talked about molarities, I said 10 molar is really concentrated, very little water, okay, kind of eat your face off molarity. By the way, you can have concentrated strong acids and concentrated weak acids, okay? Concentrated strong acids, for example, 10 molar HCl versus 10 molar acetic. Okay, so not to be going on a tangent here, but concentrated means less water, not its propensity to dissociate. Okay, so when you look at something on the order of 0.000, let's see, 0.00075 molar, that's not only dilute, that is really dilute. Really, really, really dilute. And you can see what it does to the pH. So very dilute, pH is still about 4 pH units below neutral. 4 pH units is 10 to the 4th, or 10,000 times more H plus in this solution than you would have in neutral water. And that's where the problem is. Okay? Now sulfuric acid is diprotic, which means you get a twofer, so to speak. Single arrow, 2H plus, SO4 2 minus. So if I have 1 sulfuric acid, I have 2 protons. If I have 100 sulfuric acids, I have 200 protons. So if I have 3.65 times 10 to the minus 6 molar sulfuric acid, and it completely dissociates, then the amount of protons that I have is 2 times this. Okay, so that's going to be 7.30 times 10 to the minus 6 molar sulfuric acid solution. This, however, is your concentration of H+. So all you have to do is put it into pH equals negative log of H+, pH equals negative log 7.3 times 10 to the minus 6. Okay, so let's see if we can see this on my calculator here. So I'm going to have to set it down. So log 7.3 EE minus 6 end parentheses. Okay, so there's what I have in my display. Equals. And I take the negative of what's in my display. So that's negative 5.1, or our pH is equal to 5.1. Okay, so an appreciation for 10 to the minus 6, 0.12345,730 molar. Okay, so that's the molarity of our sulfuric acid, and you can see that we're still 2 pH units below neutral. Okay, so it is still 10 squared, or 100 times, give or take, more H plus than neutral water. Okay, so moving forward, what we want to do is we want to move away from strong acids and strong bases and start looking at, well, how can we do better at getting that closer to physiological pH that will promote life? Okay, how can we get the H plus ion concentration when we have pH? pH equals negative log of H plus. 8 equals negative log of H plus. Move the negative, and we get negative 8 equals log of H plus. And the question is, how do you solve for log? How do you arithmetically get rid of log? Well, you can try to divide log on your calculator, but you'll see that you get an error. So what you need is the reciprocal function of the log, which is 10 to the x. So we're going to take 10 to the x of both sides. The math people would hate this, but I do it anyway. So our H plus ion concentration is 10 to the minus 8th, or 1 times 10 to the minus 8th molar is our H plus ion concentration. Now, how would you check your work? Well, you would check your work by putting 1 times 10 to the minus 8th into your calculator and then push log. Except on my calculator, I have to push log first. So log 1 second EE minus 8 and parentheses equals negative negative 8, which is what I expected. Okay? In the next segment, we will work some more on a few more problems, and then we will move ahead to acid-base reactions.